Here we're going to look at reducing to roots, or simplifying as much as we can. But notice one thing to be careful about is I can't combine these under the same one because one is squared root and the other one is fourth root. And so something I can remember is if I write these as exponents, they might be easier to try to figure out how to make them the same. So square root is the same as something to the 1/2 power. So this was all square root. This is all to the 1/2. And fourth root is the same as something to the 1/4 power, right? The denominator tells you what root you're taking. So now I can see, well, if I want to put that exponent on all of these things, this is like a to the 1/2 times b to the 6/2, which reduces to 3. I'll write 6/2 to begin with. And then here we're putting the 1/4 in here. A to the 1/4 and 2 times 1/4 is 2/4. Alright, so what's the common denominator we could turn them all into? Well, first off, let's see. It looks like I could reduce this one and this one, but I'm probably just going to have to multiply them by something anyways, because 1/4 I can't reduce, and 1/4 and 1/2, the common denominator is 4. So I want denominators of 4 on all these. So these two are already set, so I won't mess with them. These two, to turn them into fourths, I have to multiply by 2/2. So I end up with a to the 2/4 times b to the 12/4 over a to the 1/4 b to the 2/4. Why is that useful? Now that they're all have a 4 in the denominator, it's saying it's the fourth root of all of this, or I can think of it as the 1/4 is on the outside of the parentheses because every single one of them has its own divided by 4. If I look at it that way, the fourth root of everything, a to the first, b to the second, now I can see if I can cancel stuff, where before I couldn't. I had to do the exponent before I could get in the parentheses. Now I've noticed, hey, everything's to the 1/4, so I could pull that on the outside. So we'll see what's going to cancel. We end up with an a and a b to the 10th, and all to the 1/4. Also, another way to write to the 1/4 is to say we're taking the fourth root of all of that. Now, sometimes you'd be done at that point, fourth root of a, b to the 10th, but it looks like b to the 10th has enough where maybe we can't take the perfect fourth root of that, but we should be able to free some of the items from the fourth root. So if we take this, I have fourth root of a, and I can't take the fourth root of b to the 10th, but I could do b to the 8th, and I'd have, what, 2 left over? So what's fourth root of b to the 8th? B squared. If I did b squared times itself 4 times, I would get b to the 8th. So b squared is the only part there I can free from the fourth root. And then a and b squared are left underneath. And so there's that simplified all the way, b squared times fourth root of a, b squared.